So welcome to the last session of day 4. So in the last session, we have P. Madhu sir. He is now the strategist at madBlocks Technology Private Limited. He is also the mentor for change in Atal Innovation Mission. Prior to that, he also worked for ORL Makers Garage as a founder, as well as Oracle Research Lab as a founder. He has very high experience in the industry field. He worked in the field of IoT and cloud computing in the last couple of years. So, sir will going to cover the AWS IoT core as well as something about MQTT broker tomorrow, as well as about Google Cloud and how we are going to send, receive messages using the IoT core, using various toolkits like Raspberry Pi. And also, sir will tell you about the sensory data using ESP32. So these are the couple of sessions will be covered by sir in the next 2 days, including this particular session. So I request Madhu sir to please continue with this section.
Hello, am I audible, sir?
Yes, sir, your voice is audible.
Okay. So very good evening, one and all. Welcome you all to the FDP session on Internet of Things. So I'm very warm, I'm glad to be here on behalf of madBlocks Technologies. So I used to work as a director and strategist at madBlocks Technologies, and also I'm a certified IoT expert. So I'm working on IoT from the last 8-9 years. So I started working on IoT since 2012. So that is a era where people are talking about internet and Internet of Things, because that is a time where your data plans are becoming cheap. So today I'll talk about how to build IoT use cases on Raspberry Pi using Python, and also today I'll talk about how to read data from sensory devices, because you need sensory devices around IoT if you want to collect data, because data is very important in IoT. Today in the next 1.5 hour session, so I'll be talking about how to create a Python script on Raspberry Pi, and how to read data from Raspberry Pi, and also how to push data to cloud. So these are the brief agenda which I go into share in this next 1.5 hour session. So let me share my screen. So I warmly welcome you all to the session once again. So hope you're a bit tired with I guess from the morning, from the afternoon. So we are having some sessions here. So I guess you're a bit tired, but I'll make you feel better, because I'm going for a direct practical hands-on. So before I talk about practical hands-on, so let me share my presentation. So my presentation is everything available in GitHub. I'll share my screen. I'll also push my GitHub link of the session in the chat box, so that you can also go through that. And today I'll be talking about, as I said, what is a complete IoT outline. Let me share my screen. Okay, hope my screen is visible and my audio is also clear.
Yes, sir, very clear.
So if you have any questions and related to the session, you can scan the QR code which is displaying on the every slide on the left top. You can scan the QR code. It will take you to my WhatsApp. You can push any query if you have an it, and also you can join me on my account, which is very active, with name Madhu Parvathaneni. So you can type in LinkedIn. You can join me on LinkedIn, or if you have any question, you can drop me a mail on mad@madblocks.tech. So today I'll be talking about how to use Raspberry Pi, and also how to use Arduino, how to read data from sensory devices using Python and C++. So before we get into the practical hands-on, let me talk about a complete IoT outline. So what is IoT according to me, which I observed in the last 8-9 years. So around IoT, and then we'll talk about what is Raspberry Pi. If you're having awareness on Raspberry Pi, I'll skip session 2. If not, I'll simply outline the Raspberry Pi. And in the session 3, I'll be talking about how to use, how to read data from Arduino and how to push this data to the Google Colab. So today I wanted to demonstrate on data collection. So, and when data collection is concerned, so we have to collect the data from the end devices and we have to push the data to the cloud service providers, right? So where you have a database center, database server and all. But here, as of now, today, I'm not using any kind of cloud service. I'm just simply using Google Colab. So Google Colab is a collaborative Python notebook which is deployed on the Google Compute Engine. So I just wanted to communicate with Google Colab by using simple MQTT protocol. So let me jump into the session. So what is IoT? So according to me, IoT is a 4D technology. So for me, IoT is not about internet. IoT is all about data. So IoT is all about intelligence. So intelligence is very important when IoT devices are concerned. So today in our daily life, we are surrounded by connected devices. What are these connected devices? Connected devices are nothing but, when you look at a normal TV, so your TV will be having hardware and software, and it is communicated through a TV remote. And when you look at AC, it is also having hardware and software, which is communicated over an AC remote there. And when you look at various kinds of devices like smartphone, or when you look at laptop, or when you look at the washing machine or refrigerator, so everything you look at, so you have a computer device in it, and you have an hardware and you have a software. And when you look at embedded systems, so embedded systems are all connected devices. They are connected, so they are programmed, so they are static intelligence objects. So when embedded systems are concerned, so in various places people get confused in between embedded systems and IoT systems, because in IoT systems also you'll have hardware and you will have software. So so here also in IoT systems also they does a specific task. So they are not like general purpose systems, right? They are like the embedded systems here. So IoT systems are embedded systems, but embedded systems are not IoT systems. So let us understand what is the difference between an embedded system which is having integration of hardware and software, and which does a specific task. But when you look at ATM machine, so ATM machine is an integration of hardware and software, which has an internet connectivity. So having internet is that IoT, or having internet is an embedded system with internet device there. So when you look at ATM machine, so ATM machine is having hardware, ATM machine is having software, and ATM machine is also having internet connectivity there. So can we call that ATM machine as an IoT system there? We cannot call it, right? So then what is the difference between an embedded with internet and with IoT system there? So when you look at in the last 5 years back, I visited an engineering college in Andhra Pradesh, demonstrating project which is related to smart automation. So where they have controlled the device through a Bluetooth, which is connected on the hardware, and they have used a smartphone. So they have built a mobile application wherein smartphone is also having a Bluetooth connectivity. So through Bluetooth connectivity, they control the bulb, and they said that is an IoT device there. So if you look at the scenario, the smartphone is communicating with hardware through a Bluetooth communication. Can you call it as an IoT system or not? So there also it's a connected system, that is also an embedded system, but people calling it as an IoT systems there. So we have to understand the difference between an embedded system and IoT system. So if you could understand the differentiation there, then obviously you can talk about what kind of IoT devices can be built on the architecture here. So when you look at, I will take a simple example. I hope you are good at C programming language. So I always, in every IoT FDP, I used to say that what is the difference between an IoT system and an embedded system here. Text pad is simple. So let me write a simple snippet here, equal to printf percentile d comma a, and int a printf or scanf percentile d ampersand a, and printf percentile d comma a. So when you look at the difference between these two snippets, so once in first snippet, if you see, we have int a equal to 2. So the value of a is 2 always, which is assigned in the program, and when you print this A, then obviously 2 will be getting printed. So when you run this program 1 million times, so when you run this program 2 million times or 10 million times, always the value of A is 2 only. It means that the value of A cannot be changed. So which means that in embedded systems, the intelligence is programmed. And for example, say when you look at a shopping mall, when you enter into a shopping mall, so you will be having an entrance door. So the entrance door will be connected with motion sensor. When a motion is detected, your entrance door will open. So when you have that kind of scenario, you have an embedded system there, right? So you have a hardware, you have a software, and you have a sensor. What sensor is doing there? Sensor is simply automating the door. So when a motion is being detected, then immediately your door is open. So which means that you have a sensory device. Though you have a sensory device, we cannot call it as an IoT system. Though you have an automation there, you cannot call it as an IoT system there. So which means that your intelligence is your program is instructed in the microcontroller, which is available there in such a way that, so whenever a sensor is detected, your door should open. That is a program instruction which is written on the microcomputer, and you call it as a simple embedded system. Then what do you mean by an IoT system which has been deployed there? For example, say you have you have an IoT device connected to the door. So whenever I walk into a shopping mall, if the door welcomes you through a Google Assistant prompt message, says that welcome Madhu into the shopping mall. So last time you have visited so and so shop. So today also you have discounts on this shop. And last time you have visited, you have purchased so and so product, and you have it's a similar product in a different shop with less discount and all, with more discounts and all. So whenever your device or your door is communicating with you in such a way that it gives a smart notifications onto the mobile phone, then obviously that IoT device which is connected to the door is simply an IoT system, right? So which means that if your data is interpreted, so if your data is interpreted on IoT devices, if IoT devices are able to communicate with you in a smart possible way, then obviously you can call it as an IoT system. Which means that if you look at the second snippet, int a scan of percentage ampersand a, which means that the user can able to enter a different value for a, which means that user to user, parameter to parameter, time to time, the value of a can be changed. The value of A can be changed from time to time, from day to day, from user to user. So last time I have visited one shop, so say the other user have visited a different shop, which means that your data is not constant. Your data, so whenever your smart door wants to communicate with you, it has to understand who has walked in, what kind of things is done on the when he visited last time. So based on that, the data has to be interpreted, and based on that, the notifications has to be pushed onto the mobile phone, which means that your door is able to communicate with you, which means that your data has been interpreted there. For example, say, so tomorrow morning you have an appointment. So say your manager or your head of the department has given some instruction saying that you have to come early to the college, or you have to come early to the office. Say he has pushed Google calendar invitation. So say an event is is listed in the Google calendar. So when an event is listed in the Google calendar, what Google Assistant has to do is, Google Assistant has to understand that there is an upcoming event. Then immediately it has to set the morning alarm. Once a morning alarm ticks, then immediately it has to send a data to the greaser inside the washroom. So the greaser has to push data to has to push a request to the temperature sensor, and the temperature sensor has to send the room temperature, so that the water warm temperature will be set accordingly. And once the greaser is ready with warm temperature, obviously it sends a notification to the Google Assistant, and the Google Assistant is intimating to the user that your water is ready to have bath there. Then immediately once the user comes out of the washroom, whenever he completes the bath, then immediately the door will identify a notification to the coffee vending machine, and the coffee vending machine starts preparing coffee there. So all these devices, if you see, all these devices are communicating with each other. So it is not dependent on user, it is dependent on data which is given by user there. So which means that the user data is getting interpreted. So without any communicating with user, all the data on the devices are talking to each other. When you have these kind of scenarios, then obviously all you're surrounded by smart devices there. So in IoT, you have a difference between a connected device and a smart device. So the next up in the upcoming years, after 5 6 years, we will be surrounded by smart devices. So smart device in the sense, say, if you are continuously these days, we are doing work from home from the last 5 6 months. So daily, I used to sit before the laptop for about 8 9 hours daily continuously, and my chair wants to say that you're sitting for a long time, have a walk for a couple of minutes. So which means that if your chair wants to say something to the user, then your chair is smart there. So how the chair has to understand that you're sitting for a long time? So there should be a sensing unit. So that sensing unit keeps reading the data, and that data will be interpreted on the chair. So that chair wants to communicate with you. Say if you're not drinking water from the last 1 1.5 hour, then immediately your smart water bottle says that please drink water, otherwise you'll get dehydrated. So your work will not be done there. So if your smart water bottle is giving some kind of recommendations there, then immediately say, if you're if the alarm is on, if you're not waking up, your bed starts vibrating, so your bed wants to communicate with you in order to wake up you. So it means that all the devices are talking to you. When all the devices are talking to you, then obviously, these kind of devices are smart in nature. So before 2012, if you look at, all the devices are dependent on user instruction. So if the user gives an instruction, then only they are getting operated. But today and tomorrow, if you see, all the devices are dependent on user data rather than user instruction there. So user data is very important. So all this user data will getting interpreted on the machines, and the machine started understanding what kind of action has to be done, and each device will be communicating with the neighbor devices based on the application context. And all these neighbor devices starts responding, starts giving a freedom to the user can do their own work. And all these devices will keep helping the user through a Google Assistant. So not only Google Assistant, you need an assistant. After 5 6 years, after 2025, everyone needs an assistant, because we will be busy, because we in order to get sustained, we will be busy in different works. But your assistant, which is deployed on the smartphone, will keep assisting you, will keep reminding you, and say, if you say after 2025, if you ask your Google Assistant to book a ticket, to book a movie ticket in a respective theater, then it starts booking the ticket. And if you ask the Google Assistant to get some the food from different applications like Swiggy and Zomato, it starts booking the food on the mobile phone there automatically when you give an instruction there. So all this data, which means that your Google Assistant can able to do all kind of stuff, based on the data coming from user. So you data rather than user instruction, it is dependent on user data. In the similar way, in IoT scenario, data is very important. That is why I used to say IoT is a 4D technology, wherein D is nothing but data. So if you want to build some kind of IoT devices, then obviously data collection is very important. That is why in the first layer I used to say data has to be collected. So once you start collecting the data, so based on that, you can do some data analysis, right? So if you want to predict, if the devices wants to understand the data, then obviously at some point of time you have to collect the data. Once the data is collected, you have to send that data, you have to store that data. If you want to store the data, you cannot store on the device, because your devices will be having only kilobytes of memory, sometimes megabytes of memory. You cannot store the data coming from sensory devices, because your microcontrollers will be operating in microseconds. For every second you get very good amount of data. So for every minute, for every hour, for every day, you get a very good bulk data. So you cannot store that data on the device. If you want to build some kind of intelligence on the data, then you have to study the data, you have to understand the data. So if you want to understand the data, you have to store the data in a centralized place. So when you store the data in the centralized place, then only you can able to study the data, because all the data has to be collected at a centralized place, because you will have multiple number of devices. So all multiple devices will be pushing the data to the central server. So if you want to store the data in the central server, that central server can be accessed from any place at any point of time. So that is where people talk about cloud. So what is cloud here? Cloud is nothing but a place, nothing but a computer, which can be accessible by through a restricted access from any time, at any point of time, from any place, through an internet connectivity. So you have a cloud, something like public cloud or private cloud. You have a computer device which is hosted. so that the server will be hosted on the cloud, so that server will be communicated with all the sensory devices. But through if you want to create a connectivity between the sensory devices and the cloud, you need an IoT gateway. So what is this IoT gateway, and what is this wireless sensor network here? So in IoT, in most of the places, why people need a wireless network here, that is what you have to understand. So when you have more number of devices to get communicated over internet, you cannot provide internet to all the devices. So that is why we go for divide and rule. For example, say in a college scenario, internet is like principal. So will there be a principal for every department? No, right? So you will have only one principal, and you have 5,000 students. For 5,000 students, you have only one principal. For 5,000 devices, you have only one internet connectivity. For 5,000 devices in the industry or 5,000 devices in the agriculture field, you have only one internet connected device. You have only one internet connected device. How do you share that internet? How do you share that principal to the all 5,000 students in the college? Then obviously what people do, people create a class teacher. So what class teacher will do, every class, for every bunch of 100 students or for every bunch of 60 students, you will have a class teacher. So what is this class teacher? Class teacher is nothing but a representative of the class. And what class teacher will do, class teacher will be connected with head of the department, right? Because you have multiple number of classes, so all the multiple number of classes will be connected with head of the department, and all the head of the departments are connected with principal there. If you look at that kind of scenario here in IoT also, you cannot provide internet to all the end devices, to all the sensory devices. You cannot provide internet. That is why what people do is people create an IoT gateway. IoT gateway is nothing but a hub which is having heterogeneous wire and wireless networks embedded on it, which means that IoT gateway. So IoT gateway will be the coordinator, which is of it is having Zigbee network embedded on it. It is having a Bluetooth network embedded on it. It is having a LoRa network embedded on it. It is having RS-232 network embedded on it. It is having RS-485 network embedded on it, which means that your devices can share data to IoT gateway through Zigbee network. Your IoT devices can share data through Bluetooth to the IoT gateway. So all the IoT devices through LoRa network can able to share data to IoT gateway. So what IoT gateway will be doing there? IoT gateway is trying to read the data from all the devices, where all the devices are connected in heterogeneous wire and wireless networks here. So why? Because you cannot provide internet to all the devices. So that is why if you look at smart agriculture, in the smart agriculture, for 1 acre of land, you will have thousands of plants. So when you have thousands of plants, you cannot provide internet to all the plants, right? So you will be dipping a sensor here and there across the field, and all the sensors has to get the data. That data has to be posted to cloud. Then what people do there? People create a network of sensors. So people create a network of devices. Through the network, they will be communicating with IoT gateway. So when you have 100 devices in the agriculture field, so what people do, 20 devices, 25 devices, they create a Zigbee network. So all these 25 devices will be communicating over Zigbee network. All 25 devices will be communicating over Bluetooth network. So some 25 devices will be communicating over Wi-Fi network. Some 25 devices will be communicating over the radio frequency network there, which means that all the networks will be available there, and through each network only few devices will be communicated, and that wireless network will be created. So you need a wireless transceivers in between sensory devices and IoT gateway. That wireless transceivers will keep transmitting the data, and the IoT gateway will be receiving the data. Once the data is received by IoT gateway, then it starts pushing data to the cloud, because in agriculture you have only one IoT gateway. And when you look at smart home scenario, you will have only one IoT gateway. So what IoT gateway will do, IoT gateway will push data to the cloud, and the IoT gateway will be connected with all the coordinators. So principal, when you look at principal will be connected with all head of the departments. So head of the department is nothing but coordinator there. So so your IoT gateway will be connected to all the coordinators of the network, and each coordinator will be connected to end devices there through a wireless network, and all these devices will be communicating data to coordinator through a round robin scheduling or priority scheduling. So based on the scheduling algorithms, so all these devices will be pushing data to coordinator, and the coordinator is pushing data to IoT gateway, and IoT gateway is pushing data to cloud. So in the cloud you will have a database server. So when you have a database server, your data will get stored. So once the data gets stored, so you need a data visualization to understand what is the data is all about. So there comes the concept of there people called data scientists. So what data engineers, so what data scientists and data engineers will do, they start understanding the data. So by using various data visualizations, once they start understanding the data, they correlate the data with the help of mathematical models. When they start correlating the data with the help of mathematical models, then obviously machine learning comes in. So they create a machine learning model, and when they create a machine learning model, then obviously they start predicting, the machine learning model starts training themselves, and they start predicting the data. Once a machine learning model is able to predict the data, then that machine learning model will be deployed on the IoT gateway. Once the machine learning model is deployed on the IoT gateway, local decision can happen there. So so in the when local decision is happening out there, so which means that all the devices are communicating with each other through an IoT gateway. And IoT gateway, in the similar way, when you look at college scenario, if you get any issue in the college, then the principal will be solving it. If the principal is unable to solve the issue, then only the management comes in. So here management is like a cloud. So whenever IoT gateway is unable to solve the issue, so then obviously cloud comes in, and cloud will be connected with IoT gateway through internet connectivity. So every data which has been pumped to IoT gateway will be stored in the cloud for a reference there, and this cloud will be connected with mobile apps. So if people needs mobile app to interact with IoT devices, so the mobile data to cloud, and the cloud will be pushing data to IoT gateway, and IoT gateway will be pushing data to wireless networks there. So on the cloud, your data will be stored, your data will be predicted, your data will be interpreted there, and data will be will be bulk end devices. Then obviously how security is created, that is more important, right? Data security, which is like information security, is very important. That is why people are talking of cryptographic algorithm that can be implemented on the end devices. If the sensory data is encrypted on the device, then obviously your data will be bit secured, and that data will be pushed onto the IoT gateway. So IoT gateway will be pushing the encrypted data onto the cloud. So on the cloud, you can run decryptive algorithms, or you can use something like blockchain architecture. So when you use blockchain architecture, then obviously it is very difficult to tamper the data, and it is difficult to hack the data. Even though when data is being hacked, then obviously it will send a notification across the network, and we can easily identify. And when in IoT, if your server goes down, if your cloud server goes down, the day before yesterday also the Google service goes down for a minute. So which means that when your server goes down, then immediately in a decentralized and distributed network, so you will be having different types of servers running in parallel. If one server goes down, the other server will be inactive, so you can easily interact, and you can create one kind of the mechanism there which can be implemented on the cloud and between the devices there. And this is a simple IoT architecture which I used to follow every time if I want to develop any kind of IoT solution, because you need group of devices which communicates with each other in different networks. So I will put an IoT gateway. Say if a Bluetooth device wants to communicate with a Zigbee device, so they cannot be communicated directly. So the Bluetooth device will be connected with IoT gateway in a Bluetooth network. So Bluetooth device will be sending data to IoT gateway, and the IoT gateway will be bypassing the data to Zigbee device through a Zigbee network there, which means that the heterogeneous devices are also getting communicated with the help of IoT gateway. So IoT gateway is nothing but a place where all these networks are deployed. So today, if you see, you have a Wi-Fi router. So what Wi-Fi router will do? Wi-Fi router is producing a Wi-Fi network. So it is producing a Wi-Fi network across the across the home scenario. All your laptops, all your mobile phones are joining into the Wi-Fi network, and your Wi-Fi router is getting communicated with all the end devices like laptops, mobile phones, and all. But after 5-6 years, your pillow needs internet, your curtain needs internet, your bed needs internet, your water bottle needs internet. So when all these devices needs internet, you cannot provide internet through Wi-Fi routers. That is why IoT gateway comes in. So IoT gateway plays a vital role. IoT gateway is nothing but a processor. So which means that a high-end processor will be deployed in IoT gateway, because you cannot use a microcontroller kind of thing in IoT gateway. So that is why there is a need of Raspberry Pi. So why people talk about Raspberry Pi in IoT scenario? If you want to develop any project on IoT architecture, so gateway is very important. So what is this gateway? Gateway is nothing but a device which is connected with cloud, and a device which is connected to all end devices through a different wire and wireless networks there. And people talk about Raspberry Pi. So Raspberry Pi is nothing but a computer device, which is nothing but a processor. So we cannot use any microcontroller as an IoT gateway, because microcontrollers will be operating at low speed, and also microcontrollers execute. So you have a super loop architecture in microcontrollers. But when you look at microprocessor, you have multi-threading and multi-processing. So when you have these kind of capabilities on the processor, then it is easy to handle multiple networks. So when you have multiple networks, then obviously these kind of processors are very important, out of which this processor Raspberry Pi is of very low cost, and it operates at 1.2 gigahertz frequency. So which is like gigahertz frequency is not available in the microcontroller series. In the microcontroller series, if you look at, you have a frequency of megahertz, but when you processor, you'll have gigahertz processors. So out of which Raspberry Pi is bit cheap when you compare with the different processors available for IoT in the market. So Raspberry Pi is nothing but my IoT gateway. I used to use Raspberry Pi as an IoT gateway because Raspberry Pi is a credit card size computer. The size of the Raspberry Pi is very less, and the cost of Raspberry Pi is less when you compare with the remaining processor boards. And also the power consumption is also less, so it consumes less than 5 volts and 3 ampere power in terms of Raspberry Pi, the latest model. And Raspberry Pi was designed by a computer scientist of name Urban Upton in 2009, where he started introducing Raspberry Pi to these school kids, because in South African schools there was no computer education. Then he started building this Raspberry Pi, which is of low cost for teaching computer education in schools. But later in 2010 2011, the community across the globe started exploring Raspberry Pi as an alternate, IoT computer. So people started using Raspberry Pi as an IoT computer because its size is less, so it is a very good fit in different gateway applications, because people need a processor in building an IoT architecture, because by using a simple microcontroller they cannot do the task. So this was very popular across the community of IoT. So daily, I mean, every year 3 million units of Raspberry Pis are getting sold. And Raspberry Pi is open source and works on Linux operating system. That is also the second advantage of Raspberry Pi, the community of IoT, because the operating system is Linux and Raspberry Pi is open source. You have, when the software is open source, you'll have a good community support. So when you have a good community support, then obviously you have no need to develop the application from scratch. So if there is nothing to develop from scratch, then obviously people love it. So that is where Raspberry Pi become a developers friendly processor. So no need to write from scratch, everything is available in Raspberry Pi. So that is the reason people started using this Raspberry Pi in IoT scenarios. So Raspberry Pi is the website, the community page of Raspberry Pi is raspberrypi.org. So the documentation and the softwares are available in raspberrypi.org. You can download the softwares and you can purchase the hardware from Amazon or Flipkart. Then you can start developing some projects on Raspberry Pi here. So Raspberry Pi is very popular, as I said, because it is holding an open source Linux operating system called Raspbian. So Raspbian is an operating system from Raspberry Pi community for using Raspberry Pi boards in different IoT applications. So Raspberry Pi is not just a great platform for building IoT, but also for learning IoT. Say if you write a project, proposal for DST in addressing various kinds of problem statements. Say if you want to use IoT there, then simply you can start building some applications as a prototype by using Raspberry Pi. And when you use Raspberry Pi, no need to take licensing, and also you can start quickly using this Raspberry Pi, and you can start developing applications over there. And Raspberry Pi is also very good fit in various image processing applications. Today we have Raspberry Pi 4. So in Raspberry Pi 4 we have a RAM capacity up to 8 GB. So people are also using in low-end machine learning applications on Raspberry Pi. In data science projects also people started using Raspberry Pi. And Raspberry Pi is available in different models, say Raspberry Pi, Raspberry Pi 2, Raspberry Pi 3, and Raspberry Pi 4. So Raspberry Pi 4 is the latest board from Raspberry Pi community. So Raspberry Pi 4 is having 2 GB, but in Raspberry Pi 2, Raspberry Pi 3, we have only 1 GB of RAM capacity. But when you look at Raspberry Pi 4, we have 2 GB, 4 GB, and 8 GB RAM capacity. So your speed is very high when you compare with the Raspberry Pi 2, and Raspberry Pi 3. So Raspberry Pi 4 is bit faster. So Raspberry Pi is having different kinds of peripherals like USB ports, HDMI ports, LAN port, GPIO header, camera port, screen interfacing. So you have different types of peripherals associated with Raspberry Pi. You can easily replace your cabinet with Raspberry Pi. So according to me, Raspberry Pi is nothing but a cabinet. So when you look at Raspberry Pi board, you have processor, high speed processor on Raspberry Pi, which can be operating at 1.5 gigahertz. So 1.5 gigahertz processor will be there on Raspberry Pi, and also along with processor you will be having RAM capacity. You have 2 GB, 4 GB, 8 GB of RAM capacity on Raspberry Pi 4. So along with RAM, so you have different types of USB ports where you can connect USB keyboard, USB mouse, or you can connect USB GPRS modem. So if you want to use Raspberry Pi in agriculture scenario, or if you want to use this Raspberry Pi in a standalone place, then obviously GPRS modem is very important, and you can interface GPRS modem at USB port of Raspberry Pi, and it starts getting internet. So when it gets starting internet, you can create a network of wireless devices by using various wireless networks there. Then you can easily push data to the cloud by using this Raspberry Pi as an IoT gateway. And it is also having Ethernet port, gigabit Ethernet port is also available, where you can plug LAN cable when you have a LAN cable facility in the place where you deploy it. And it is also supported with 3.5 mm audio jack, so you can connect audio speakers and all. You can connect USB speakers, and also you can connect mic system at 4-pole stereo audio port there. And you can also connect onboard camera. So when you look at laptop, you have onboard cameras. Onboard cameras can be connected at CSI, so which is nothing but camera serial interface. So beside camera serial interface, you have HDMI port where you can connect normal TV monitor, to the HDMI port of Raspberry Pi. And the power, as I said, 5 volts 3 ampere. So 5 volts 3 ampere is the power which is given to Raspberry Pi 4. So Raspberry Pi 3 needs 5 volts 2 ampere, so this needs 5 volt 3 amperes. And you have display serial interface. So the display serial interface is also available on Raspberry Pi, where you can connect onboard screens. So you have a micro SD slot. So this is very important for Raspberry Pi, because Raspberry Pi doesn't support onboard hard disk. So you need to plug your SD card on the backside of Raspberry Pi, and your operating system has to be booted on the SD card, and that SD card will be holding the operating system called Linux operating system, which is of Raspbian. So that is a variant from Raspberry Pi community, and that will be acting as an the program memory. So the SD card will be acting as a program memory, where you can store all the program on the SD card. So, and you have onboard Wi-Fi and onboard Bluetooth stack available on Raspberry Pi. So you can easily create Bluetooth network or Wi-Fi network onto the on the Raspberry Pi here. Or if not, if you want to create some kind of LoRa network, then you have to connect a GPIO header. So if you want to connect actuators or sensors, GPIO header. GPIO header is also available on Raspberry Pi. On this GPIO header, you have UART, you have IC, and you have SPA ports readily available, and you can start programming this Raspberry Pi. So Raspberry Pi supports different C++, Python, Java, Ruby on Rails. So these are the different programming languages which are supported by Raspberry Pi. So I will be using Python, because Python is simple, developers friendly programming language in designing various kinds of applications here. So in this FDP session, so in my sessions I will be using Python, C++, and MicroPython. So these are the 3 programming languages which I use in developing various use cases. So Python is 30 years old. So it's a very old programming language, and it is a without any computer background also you can easily get Python. So it is simple. It's a developer friendly programming language, because of little friendly syntaxes will be there on Python. So that is why Python is heavily used. And Python has broad standard libraries. So when you have a 30 years old friend, so sitting beside you, so that friend will be having a lot of experience and expertise. And so I will be using the friend's expertise and experience in molding various IoT applications, because it has broad standard libraries. So when it has broad standard libraries, obviously no need to write from scratch. So everything is available in terms of library. We have develop our source code. So that source code will be connected with the libraries which are available in Python, so that we can easily develop some kind of use cases. So in the next 1.5 years, so it's difficult to write from scratch in next 1.5 hour in order to demonstrate various use cases. But when you have Python, so when you have Python something, when you have programming language like Python, so it's easy for us to develop application the next 1.5 hour in related to the IoT use cases here. So according to me, Raspberry Pi is nothing but a cabinet. So the cost of Raspberry Pi will be around 4,000 to 5,000 rupees based on the version that you use. So you can easily use this Raspberry Pi and various IoT use cases. Right away, I'm having Raspberry Pi, and also I'm having Arduino board with me today to demonstrate the use case. So that's all about the Raspberry Pi. Okay, so the next session here is practical hands-on. So let me share my GitHub link. Okay, that is having all the prerequisites and all. So let me share this. Whether I guess I have shared my GitHub link. So in the GitHub link, you have the presentation of today. Okay, and also you have different programs which I'm going to write. Okay, so let me talk about library which I said. So no need to write from scratch. Everything is available. So this is a library which is has to be installed on Raspberry Pi. So which is sudo pip3 install -mqdt. So this is a MQTT library. So I'll talk about what is MQTT, but this library we have to install it on both Google Colab. So I don't know whether you are aware of Google Colab or not, but we have to install this library on Google Colab and also on Raspberry Pi. So let me talk about prerequisites. So I need Arduino USB cable. So why we need Arduino? When you have Raspberry Pi. So Raspberry Pi can be used as an IoT gateway, but Arduino will be used as an end device. So you need a device which reads the data from sensor, right? So because Raspberry Pi GPIO, you cannot connect analog sensor with Raspberry Pi. All the GPIO lines of Raspberry Pi are digital by default. So when they are digital, you can interface only digital sensors. You cannot interface analog sensors directly with Raspberry Pi. So that is why generally what people do is people use external analog to digital converters, or people use something like Arduino. So they'll connect sensor, and Arduino will be reading the data from sensor, and that data it will be communicated to Raspberry Pi through a different wire and wireless networks. So we need Raspberry Pi and also the sensor, some analog sensor. So here as of use case, I'm using soil moisture sensor, which is analog, and also I'm having Arduino and USB cable. Okay, so these are the prerequisites which I did before I jump into the session. So I am all these prerequisites right away. So let me look into some questions. Okay, if you have any questions so far. So this link will be available after the FDP also. You can access my Git link even after the FDP, because it is holding all the programs for today's session, and if PPT is in the Git, so you can PPT and you can go through that. And if you have any questions, you can drop me in the chat, or you can ask me in the so you have so you can push a query. So whenever you go through that, so whenever you do hands-on, sometimes you'll be getting struck, right? So you can push your queries to the mail ID which is available in the Git. Okay, so make sure that you have this Git link available so that you can also get started. Recommend you to have Python, because these days microcontroller are also supporting Python. So with Python, you can easily communicate with database servers. So that is the reason Python is widely used in IoT. Because as I said, data you can do with Python very easily. Data analysis you can do with Python easily. So data collection you can do with Python easily. So the common language for all the layers in IoT is like Python. So when you learn Python, anyways, C will be the fundamental programming language that we learn from engineering days, right? So I guess you're good at C and all. So if you have Python, then it will be easy for you to develop various use cases and various architectures in related with IoT. Because when cloud is concerned, so again you need a server which
Sir, your voice is not audible, sir. Can someone put in the chat?
Madhu sir, you are not audible.
Hello.
Okay, sir. Okay, right, sir.
Am I audible, sir? Hello.
Yeah, you are audible now. Okay, sir. Right.
Okay. So Python. Python recommend for use cases because Python is heavily used at various IoT. So today, because IoT is all about cluster of IoT devices, embedded, which are connected with each other. So everything needs internet. Everywhere you have data. So whenever you have data, is my screen visible? Share.
Not visible,
Sharing.
sir.
What is it? Is my screen visible? It is showing.
No, screen is not visible, sir. It is showing the sharing is in process actually.
What is happening? Share content not blocked.
Your voice is coming, sir. You can share it. Share the content.
Hello, am I audible, sir?
Yes, sir, you are audible, sir.
Okay. Let me share my screen. Check screen, sir. Is my screen visible?
Yeah, your screen is coming. I think you can share something, sir.
Okay. Now can you see, right?
Yes, I can see your screen.
Okay. So let me show you the Google Colab. So I don't know whether you are aware of it or not. So let me copy this link. Let me put it in the chat so that you can open it directly. Okay. Let me put HTTPS. Okay. So collab.research.google.com. So that is a website. So today, as we have only 1.5 hour time, so I just wanted to stream the data first. Because if you want to store the data, you have to stream the data to internet, right? So when you stream the data to internet, then obviously we can easily store the data. So that is why I'm using Google Colab. So Google Colab is a collaborative Python notebook, which is hosted on Google Compute Engine, which is associated with your Gmail ID. So if you have Gmail ID, you can easily use this Google Colab. So generally these days everyone is having Google Gmail ID and all. So you can log in with your Gmail ID on this Colab platform. So we can easily execute the Python scripts. So on the Google Colab, and you can also run some machine learning models or AI on the Google Colab. And the Google Colab is running on 12 GB to 18 GB of RAM. So it is very pretty faster than the system notebook which is available offline. So Google Colab. So when you have Google Colab, so it's a Python notebook which will be stored in the Google Drive, so that you can easily share your Google Colab with your friends and all. So I'm also using this Google Colab. You can able to see it on my screen. So let me create a new notebook. So let me create a new notebook here. So you will have this option. So when you open this Colab platform, so you will have an option to create a new notebook. So let me click on that. So when I click on new notebook, you can able to see, the Google Colab notebook is getting opened. So which means that this Google Colab notebook is getting, executed on your Google Compute Engine, which is associated with your Gmail ID here. So let me name this notebook. So after this session, I will upload this notebook to the same GitHub, okay? So that you can also download this notebook if you want to practice after the FTP. Okay. So here, this is the Colab notebook. Okay, we can execute Python scripts. So on Google Colab, Python 3 is supported. Python is available in two versions, Python 2 and Python 3. So you can able to run Python 3 scripts on Google Colab. So you can easily execute this. Okay, you can easily execute your Python scripts here. For example, say print of say NIT Warangal Warangal FDP on IoT is going good. So to say if this is your Python script, so you can easily execute it by clicking on the play button here. So every cell will be having the play button, which is run button. So you can execute that. You can click on that. When you click on that, the respective cell will be executed. You can able to see the output. So when you're executing for the first time, so it has to be connected to your Google Compute Engine. That is, it takes some time, and after that you can able to see the output directly on the Google Colab. So my point today is like, I want to collect data from sensor, and that data has to be displayed on Google Colab. If it is pushed to Google Colab, so the tomorrow what I'll do is I'll create an API. So you need an API, right? So if you're having a server on your cloud, you need an API in order to communicate, right? So tomorrow I'll be showing you how to create an API for streaming the data. But today, as of now, let me read data from Arduino. Let me push the data to this Google Colab by using a protocol called MQTT protocol. So what is this MQTT protocol? MQTT protocol is again an open source communication protocol. So it works on TCP/IP, on top of TCP/IP. And this MQTT protocol, as a communication protocol, it indirectly means that message queue telemetry transport. So MQTT is nothing but message queue telemetry transport. Your messages will be transported from anywhere to anywhere. So when you have internet connectivity, you can easily transfer your data. You can easily transfer your information when you have internet connectivity from anywhere to anywhere. So which means that it works using internet protocol. Okay, so it's something like WhatsApp. When you look at WhatsApp, what happens there? You will be having a WhatsApp application, and your friend will also have a WhatsApp application. They will be connected to the WhatsApp server. So here also you have something like server, which is connected between sender and receiver. You will have a sender, you will have a receiver. So in between sender and receiver, there will be a server. So through the server, the data will be communicated here. So MQTT protocol is a lightweight communication protocol. It was launched by a company called IBM. So they made it open source. Now Eclipse Foundation is maintaining this MQTT protocol. So if you need the documentation, data about MQTT, you can go to mqtt.org. So that is a community website of MQTT protocol. So MQTT is heavily used in IoT application because it's a lightweight communication protocol in low bandwidth also. So ideally the MQTT protocol requires less bandwidth. So bandwidth is also very important in IoT projects. Because if you have high bandwidth internet applications, then obviously the data consumption will be more. When the data consumption is more, then obviously power consumption will be more. So here in IoT, the bandwidth is very important. So this MQTT protocol needs less bandwidth for transferring the data from one end to another end. So here I am using MQTT protocol on Raspberry Pi, because Raspberry Pi is having a sensory data, and the other MQTT, the other fellow will be on Google Colab. So on the Google Colab, I want to receive data, which means that in MQTT protocol you have pub and sub. So what is pub and sub? Pub is nothing but sender. So sub is nothing but receiver. Pub is nothing but publisher. So publisher is nothing but a person who is sending messages. Subscriber is nothing but a person who is receiving messages. This kind of things will happen in the WhatsApp, in Instagram and LinkedIn. If you see, you have the same kind of communication here. One fellow will be sender, the other fellow will be receiver. What sender will do? Sender will keep publishing the data. The same data will be sent to all the receivers, because in the in the Instagram, if you see, or in the Twitter, you see, you have group of fellows, right? So in Instagram, you'll have group of followers, which means that one account will have multiple followers. So which indirectly means that one publisher can able to send messages to multiple fellows on the Instagram and Twitter. So one publisher can able to send data to multiple subscribers also. So you have one-to-one communication, you have one-to-many communication. In MQTT protocol, you can make one-to-one, you can make one-to-many communication. Today I'll be talking about one-to-one communication. So if you understand one-to-one communication, you can easily do one-to-many communication also. But here the protocol is like pub-sub model. It follows pub and sub. So in between pub and sub, in between publisher and subscriber, in between sender and receiver, you need a server. That server is called broker in MQTT protocol. And you have public brokers and you have private brokers. So in this FDP program, today I'm using public broker, but tomorrow I'll be using private broker. So I'll show you how to create a private broker, and also I'll show you how to use public broker. So out of all public, there is a public broker called broker.hivemq.com. So this is a public broker. You can use this broker in order to send messages from one place to another place in IoT. And every server, what is broker here? Broker is nothing but a communication server. So this communication server will be running on a port number called 1883. 1883 is a default broker port number of MQTT protocol. So in MQTT protocol, the topic is also very important, on which topic the messages are communicated in between the devices. That is also very important there. So in WhatsApp, you have a mobile number. So mobile number is acting like an identity. In Facebook, in LinkedIn, in Instagram, in Twitter, you have a username. Username will be acting like an identity in pushing the data. So here also in MQTT protocol, you need a topic. So as it is lightweight and it is open source, so it is heavily used in different mobile applications of IoT and various IoT devices also. MQTT is heavily used. So you can apply this MQTT protocol to IoT devices in smart home, in smart city, in smart healthcare, in smart agriculture, in smart industries also you can easily apply this MQTT protocol. So when you look at the information flow, of MQTT, say you have an MQTT broker. So what is MQTT broker? MQTT broker is nothing but which connects publisher and subscriber. So here if you see this image, you can easily understand the MQTT protocol. So you have a temperature sensor. So this temperature sensor is nothing but publisher. So this wants to publish a data called 75 degrees Fahrenheit on a topic called temperature to the MQTT broker. So then what MQTT broker will do? MQTT broker will read the data from this fellow and pushes the data to the subscribers. So we have two subscribers here. Computer is one subscriber, mobile device is another subscriber. So they are subscribing to MQTT broker. They are connected to MQTT broker on a topic called temp. That is why this data called 75 degrees Fahrenheit is being published to two devices here. So you can have n number of subscribers for a single topic. So all the n number of subscribers will be getting the data. So here this is the information flow that is being carried out between the publisher and subscriber. So all the publishers and subscribers are connected to MQTT broker. So MQTT broker is a cloud server. So it is a server which is hosted in the cloud. So through the cloud server, they will be communicating with each other using MQTT protocol. So in MQTT protocol, you have a publisher, you have a subscriber. So when you have these entities programmed by using any programming language, we can able to send and receive data. So when you do this MQTT communication between the Raspberry Pi and Google Colab, you can able to receive the data. So that is my point of using MQTT protocol here. Raspberry Pi, I'm here in Hyderabad, so Raspberry Pi is with me. But Google Colab is deployed on the Google Compute Engine of my account. So the data at Hyderabad has to be pushed to the Google Colab, right? So we have a server which is running on cloud. So by using MQTT broker, we can able to send data from my Raspberry Pi to the Google Colab. So Google Colab, we have a simple application which is running on it. So that application will be reading the data. So now let's start programming this use case. So my use case is very simple. I want to read data from Arduino, and that data I want to read by Raspberry Pi. So my Raspberry Pi has to push data to Google Colab. So this is my application today, which I'm going to demonstrate. So have you understood this? Are you all with me? So on Google Colab, I'm using Python. Okay, I'm using Python. So let me, so this is Python. So let me hit one more plus code. Okay. So Python, you can install any library. Okay. On Google Colab, Google Colab by using pip. So pip is nothing but Python package index. So by using this package index, we can install any kind of library. Okay. So pip install paho-mqdt. When you hit enter, then immediately this package will be installed on your Google Colab. So as I said, this package is not built-in package. So IoT MQTT, as I said, IoT MQTT. Okay, so you have this. Where is this? MQTT.org. Okay. So
Excuse me, sir. MQTT broker like server?
Broker?
MQTT broker like server, you mean?
Yes, broker in the sense server. So the name is called broker, but it is a server which is hosted on the cloud.
Okay, thank you, sir.
So there are open source servers. Okay, there are public servers which are public brokers. So if you type IoT brokers, you'll get a lot of brokers. Okay, out of which this broker.hivemq.com is reliable. So we can trust that broker because the information transfer rate is good in the MQTT broker, which is public broker from HiveMQ. So let me use that. So let me use this broker, which is broker.hivemq.com. So this is a reliable broker, though it is public. So you can able to see the outgoing messages and incoming messages here. So the people are using it in the real-time scenarios also. But tomorrow I'll show you how to create a private broker. So this is a public broker. We can relay and we can trust this. And you can able to see subscribers and also the bytes read, bytes written into it. and the queued messages and the MQTT sessions and all. So this is the website to see how the transfer rate is happening around the devices. Okay, so I'll be using broker.hivemq.com. This is the broker. So now what I'll do is I have a Raspberry Pi. I have a Raspberry Pi with me. So Raspberry Pi will be pushing data to Google Colab. So today, if the data is collected, tomorrow we can store it. Okay. So let me collect the data. So I have MQTT protocol here. So PAHO-MQTT is a Python library. So PAHO-MQTT, as I said, now MQTT protocol is maintained by the Eclipse Foundation. So if you type IoT PAHO MQTT, so you'll be getting the so it is a library from Eclipse. You can easily access MQTT protocol by using this library. So this library is written in C++, Java, and also in Python. So we can use. I'm using Python version of MQTT PAHO, which is installed on my Google Colab. So I'll install the same thing on my Raspberry Pi also. Let me do that. Sudo pip3 install PAHO -MQTT. So I guess it is there on my the system. Yes, it's already there on my system. Okay. So anyways, so let me use this program. So Python is again portable. So when you have a portable programming language, so irrespective of the operating system, it will operate, right? So you can easily access it. So the programs will never change. The syntaxes will be same, but the place of execution will be different. So you can execute Python program on microcontrollers. You can execute Python program on Raspberry Pis, or you can execute Python program on laptops, or you can execute the same Python program on cloud. So the Python is portable. So let me simply check whether my PAHO library is available or not. So PAHO library is available. So we can easily communicate. Okay. So let's communicate in between the Google Colab and the Raspberry Pi terminal. Okay. So this is Raspberry Pi terminal. So here what I'll do is I'll go to my desktop. Okay. So I'll create a folder. So mkdir nid fdp IoT session. Okay. So cd space nit. So as it is Linux operating system, all the Linux commands will operate here. Okay. So what I did here, I have created a directory and then I have entered into it. So here what I'll do is I will create a program on my Raspberry Pi to push the data to Google Colab. So here, if to understand that what is Google Colab, what is Raspberry Pi. So let me put a text here. So here, Raspberry Pi. So I wanted to implement MQTT protocol. I'm having Raspberry Pi and I'm having Google Colab. So on Raspberry Pi, I have to write a Python script, and Google Colab also I have to write a Python script. But this is source. So this is destination, right? So we are having data available at source. So we have a sensory data here. And that data we need to push to destination. So which is sender, which is receiver. So you can easily understand that, right? So this is sender and this fellow is receiver. So Raspberry Pi is publisher and Google Colab is subscriber. So what we have to do, we have to write publisher program on Raspberry Pi, and we have to write subscriber program on Google Colab. So if you understand this, which program where to run. So my Raspberry Pi wants to send data. So that is where Raspberry Pi will become sender. So Raspberry Pi will become publisher. Google Colab will become subscriber. Okay. So hope you understood this. You can use any kind of operating system. Okay. So as of now. So here, let me write a program. Okay. Sudo space nano space mqtt underscore pub.py. You can name it any file name. Okay. Sudo space nano space mqtt underscore pub.py. The same program will work on Raspberry Pi. Okay. So I'm doing it on my Ubuntu LX terminal. Okay, so you can also do the same thing on Raspberry Pi because it is portable. Sudo nano mqtt underscore pub.py. So I am creating a script called mqtt underscore pub.py by using nano editor. So nano is the name of the editor. Let me hit enter. So you can create an empty file. So as of now I'm creating a Python script. So what is the command here? Sudo space nano space mqtt underscore pub.py. So what is a sudo? Sudo is nothing but giving administrative privilege. Okay. What is nano? Nano is nothing but editor. So what is the mqtt underscore pub.py, which is nothing but program name. Okay, so what is the agent of this program? So let me talk about it. So hash is nothing but comment in Python. Okay, so agent of this program is to push the data to Google Colab. Then this fellow is acting as publisher, right? So Raspberry Pi is acting as publisher and Google Colab is acting as subscriber. Now here let us write the program. So it's very simple because we are using Python. So in Python what we have to do is if you want to connect with server, not only in Python, so if you want to connect with server you need a client, right? So server client mechanism has to be created. Now let us create a client. But if you want to create a client, which client you need to create? MQTT client. So we have to import a library here. So import space paho.mqtt.client as MQTT. So what is this? paho.mqtt.client. So we need a client object to connect with server. So what is broker here? Broker is nothing but server. So what kind of data flow is here? Raspberry Pi is sending data to whom? Broker. So what is this broker? HiveMQ broker. So what HiveMQ broker is doing? It is sending data to Google Colab because Google Colab will be the subscriber here, isn't it? So to communicate with server, what we need a client mechanism, right? So this fellow is publisher. We need a client in order to connect with HiveMQ broker. So that client I have imported a module. So I'm renaming it as MQTT instead of using paho.mqtt.client every time in the program. I can use it as MQTT. Okay, so I have imported the package. So let me create a client object. So I have to create a client object. Client equal to. So without client we cannot communicate with server. So MQTT.C client. So here I have created a client object. So client equal to MQTT.C client. So after creating a client object, you can connect with server. So there is no issue here. So let's connect with server. But if you want to connect with server, you need a client. If you want to create a client, so you have to create an MQTT client. So that is why we have imported the package called paho.mqtt.client. So this is a package which it will be installed when you run the previous command. So there is a command called pip3 install paho-mqtt, right? So when you install that command, so this package will be imported in your laptop or Raspberry Pi or Google Colab. So everywhere it is portable. You can install that command, okay, and you can start scripting it. Now let me write client.connect. So you have to connect with broker, right? So what is a broker? Which is nothing but server. So let me define it. So broker equal to, what is a broker name here? Broker.hivemq.com. So this is the broker name, which is nothing but server, alias server. Broker is nothing but server in MQTT. So what is a port number? 1883. So these are the details of MQTT broker, right? So we have to pass it broker comma port. Okay, so this client will be able to connect with server. Okay, so after connecting with server, what you have to do? Let me write a print statement here. Connected with broker, okay, or you can say simply broker connected. Once it is connected with broker, what we have to do? We have to send data. So let us send the data. Okay, let's send the data. So how to send the data? Client.publish. So this is a publisher, right? So it has to publish the data. So to publish the data, what you need? You need an identity, right? So here identity is called topic. Topic equal to, let's say, you can keep any topic, okay? But the topic name should be same in between publisher and subscriber. Okay, so let's say topic like, NITW, NIT Varangal /IoT. Okay, let it be the topic. So this topic, okay, let me publish topic. What message you want to push? Okay, say I want to push something like I should push sensory data, but here as of now, let me push welcome to IoT MQTT session. Okay, so this data will be pushed to whom? To this topic, onto the broker. So if any subscriber is subscribing on this topic, what they will get? They will get this message called welcome to IoT MQTT session. So that's it. So only 5-6 lines, right? So what we did here, we have imported the package. So this package is needed if you want to implement MQTT protocol in Python. So this package is a third-party package which is open source. So you can import it because we need a client object to connect with server. So what is server here? Broker. So that broker is deployed on cloud. Today we are using public broker of name broker.hivemp.com and port number is 1883 and you need a topic to get communicated. So the topic is nothing but nitw/IoT. So all the subscribers has to subscribe with the same topic. Then only they'll get communicated. Now what we did here, we have created a client object and then we have connected with server, so which is like broker using broker port number, and then we have published the data. So any questions here? So let me see the chart. Am I audible?
Yes.
So this is the program which we have to write. The same program I have shared in the Git. Okay. So okay, so let me save this program. Control X. So Control plus X. Same process you have to do. Okay, on Raspberry Pi. So you have to purchase Raspberry Pi and you have to boot your SD card with Raspbian operating system, and then you can process. You can follow the steps. I guess this session is in recording. If it is in recording, you can use as a reference. Or this is very simple. I have written in the Git notes also. So like I have given how to do that. You have to upload the this is a process of reading data from sensor, right? So as of now we are writing some test programs. Okay, anyways, I'll explain that how to do this from scratch when you purchase a Raspberry Pi. So let me exit from here. Control X, press Y and hit enter. So Control X Y, it is a save. You have to come out of this editor. Now you have to execute it, but if you want to execute this, your subscriber should be ready. Okay, so who is subscriber here? Google Colab. So we need to write a program on Google Colab also. So in Google Colab, what we have to do is we have to write a program for subscriber. Okay, subscriber. So we have to write program for subscriber. So here also we have to import the same package. Okay, so I guess it is visible. So import space paho.mqtt.client as mqtt. Okay, dot client as mqtt. Okay, so here again we have to create what? A client object, because subscriber is also not server. It is also a client. Who is server? Broker is only server. So we have to create a client object. So client equal to mqtt.C client. So we have to create a client object. Once a client object is created, we can connect with broker. So we have to connect with broker. So client.connect of broker. So what is a broker? Let me define them here. So broker is nothing but broker.hivemq.com, and broker port number is nothing but it's always fixed, which is 1883. Okay, topic. What is a topic? Topic is nothing but the same topic we have to write. So I guess nitw/IoT. Is that same? Yeah, let me see that. If they are same, then only they can communicate. Okay. So these are the details. Okay, which are like configuration details. So let's pass that broker comma port. So now let's say print broker connected. Okay, up to here everything is same. Now what we have to do? We have to subscribe, right? So this fellow is a subscriber. So we have to subscribe. Okay, we have to subscribe for what? On what? So we have to subscribe on this topic. So client dot subscribe of topic. Okay, so we have to subscribe on this topic. So whenever you subscribe on this topic, what will happen? So whenever a broker gets data on this topic, it will push the data to the subscriber. Okay, here what we have to do is we have to define a notification function. So what is this notification function? So whenever subscriber gets data from broker, so it pushes a notification. It calls this notification function. So def notification. So generally in WhatsApp, so when your friends pushes a message on your WhatsApp, what will happen? You'll get a notified on the desktop, right? So on the home screen, you'll get a notification. So here also there should be a notification. Then only you will be notified. Then you'll be seeing what message the broker has sent here. So def notification. So we have to pass what is a client object and what is a user data. So what is the data of the user that is coming from MQTT broker, and what is a message object. Okay, so always keep a point in mind in MQTT in MQTT communication, your data will be in the form of dictionary format. Okay, so this message, it will be in the form of dictionary format. So what is dictionary format? It is nothing but key value pairs. It is nothing but key colon value pairs. So here what happens here is like, as we are sending data, like, FDP is going good, right? So something like that. So here what happens is in MQTT broker, what broker will do is, for so it pushes the data in the form of dictionary format. So always your message will be having a key called payload. So this is called a key. So the value will be your message. So this is your user message. Okay, so here you have a key value pair. So key value pair is nothing but your message will be assigned to a key called payload. So that is why what we have to do is we have to print message.payload. Okay, to access the message which is pumped from the publisher part. So we have to define the notification function. In the notification function, what I'm doing here, I'm printing the message. So when to print the message? Whenever a broker sends data to subscriber, then only I have to print. That is why we have defined it as a notification function. So here what we have to do, we have to configure the notification function. So we have to configure the notification function by using a syntax like, client dot on underscore message. So on underscore message is nothing but whenever subscriber gets a message. So what it has to do, it has to call in notification function. So client dot on underscore message equal to notification function, which is nothing but whenever subscriber gets a message, so this function will be notified, and then we have to execute this subscriber on an infinite loop, because it has to run until I stop it. So client dot loop underscore forever. So forever in the sense it will be executing until you stop, right? So until you manually stop it. So it keeps waiting for data coming from broker. So let me run the program. So if you want to run the program, you can hit play button here. If you hit play button, you can able to see broker connected, and it is rotating continuously, which means that it is waiting for data, because we have loop underscore forever. So when you have loop underscore forever, it is waiting for data that has to be, pushed from broker, but broker pushes the data only when publisher pushes the data, right? So let me execute publisher program. So this is a publisher program. Let me run the publisher program. So sudo space python 3 space mqtt underscore pub.py. So when I execute the program, you can able to see the data which is getting printed here. So we have a data like, welcome to IoT MQTT session written in the program. So that data is printing here. Let me run it again. So when I run it again, what will happen here? This publisher is publishing data to broker, and the broker is publishing data to subscriber. So when I enter again, so you can able to see the data which is printed on the Google Colab there. So now your publisher which is running on the laptop alias Raspberry Pi, the data is able to display on Google Colab here. So it means that they are getting communicated through broker. So this fellow, the laptop alias Raspberry Pi, is pushing data to broker. So broker is pushing data to subscriber. So we have a subscriber called written on the Google Colab. So in the similar way, when you run this program, what will happen? The same data will be received by all of you. Okay. So when you also run the same program, you can able to get the same message, because all this to all the subscribers. So there is no limit on the subscribers here. To all the subscribers, it pushes the data from the broker whenever publisher publishes any message onto the broker there. So have you understood this? Any doubt? So clear up to this. So your terminal is pushing data to Google Colab. So any doubt here? Okay. So they're getting communicated. Okay, let me stop it. So it will be waiting until I stop. Okay, so because we have loop underscore forever here. Okay, so let me stop it manually. So when I stop it manually, you'll get keyboard interrupt. So which means that we have terminated it. Okay, so let me delete this. Okay, okay. So we have written a simple program.
Notification for what? Can you repeat, explain it again?
Which program?
Notification
Notification. Okay.
function.
Sure. So here, what is the advantage of notification function? Okay, that is what we have to understand. So if you could understand that, you can easily understand what is this. Okay, so notification is nothing but your subscribers keep waiting. Okay, so whenever it is keeping waiting, then we have to print message.payload, right? So what is message.payload? Message.payload is nothing but your message coming from publisher. Okay, so here what we did here, we have defined a function called notification. So in the place of notification, you can write you can write mom also, because that is just a name. Okay, so that's the function name. Okay, so need not be notification. Okay, so it's just a function which is defined here. Okay, and here inside the function, what type of arguments we have passed? We have passed an argument called client. So what is this client? So we have created a client object here. So through this client object, it pushes the data. Okay, so through this client object, the broker will be pushing data. So when it is pushing data, it will be holding some user data. So what is this user data? User data can be, who published the data. Okay, what kind of ID the publisher will be having. Okay, so all that data will be stored in user data, and the session ID, everything will be stored in user data. So what will be stored in message? In message, we have data like message.payload. So what is this payload? Message will be always in the form of dictionary format. If you good at if you understand the document based databases. So document based databases always store the data in the form of JSON format. So in the JSON format, you have always key value pairs. So in Python, we have a key value pair called dictionary format. So in the dictionary format, you have a key value pair. What is this key? So key is nothing but an identifier. So okay, so it will be constant always. Your key will never change. But what will be changed here? Your value will be changed. So this value is totally based on the Raspberry Pi data. Okay, it can push whatever it wants, right? So this value will not be constant. So that is why what I'm doing here, I'm accessing this value through a key. So what is this key? That key is nothing but payload. So when you look at rocket, a rocket will be holding satellite. So that satellite is called payload. What is rocket there? Rocket is nothing but carrier. So here also you have message. This is an object. Okay, this is like a rocket. What is payload here? So payload is nothing but the what you can say, it's a key. Okay, it's a key which is holding a value, so that value is nothing but satellite here. So which is nothing but that is required, that is the data coming from publisher. So that is why what I'm doing here, I'm printing message.payload. But here, this is the user defined function. I kept it as mom. Okay, you can put any name here. So the name is not
And the parameter user data, for what user data?
User data is to identify who has published, because in MQTT protocol, publisher will be publishing data to broker, right? So whenever a publisher publishes data, every publisher will be having a unique session publisher ID. Okay, so that publisher ID will be pushed to subscribers, saying that for example in WhatsApp, say I have sent a message to you, so I will be having my WhatsApp number. So that WhatsApp number is nothing but user data. So the user data will be sent to the WhatsApp server. So WhatsApp server, what it will hold? WhatsApp server will be holding user data and also message. So what is this user data? User data is nothing but what is the session ID, what is a message request, what to whom it has to send. So all this data will be stored in user data. So message, what is the message? Message is nothing but which is holding the data which is sent by the publisher there.
Okay, sir, thank you.
So here the publisher and subscriber is getting communicated. So now let us read the data from sensor through Arduino. So,
Madhu sir, one query. This is on MQTT dashboard, right? That Raspberry Pi part is MQTT dashboard? Because there are two different screens, no? I think.
Yes, I'm using this terminal, right?
Yeah, this terminal. Where is it?
So this is Raspberry Pi terminal. So this is on my laptop.
Okay. And the Google Colab in the same system?
It is also available on the same system, but I have logged in through Gmail.
Oh, I see. Achha. Okay. Okay, then fine. Thank you.
Okay. So notification is needed. For example, say when you look at publisher, when you are sending a message, okay, you need a delivery report, right? Publisher needs a delivery report. So that is called acknowledgement, right? Saying that whether the subscriber read it or not. For example, say in WhatsApp. So when you are sending a message, so what you need single tick, double tick, blue tick and all. So what are this? So these are the notifications given to publisher saying that whether message has been read by the other person or not. So that is needed for a publisher, right? So what sender needs? Delivery report. So delivery report is nothing but acknowledgement here. In MQTT protocol also you have a quality of service 0, quality of service 1, quality of service 2 and quality of service 3. So these are like in WhatsApp also you will have, if you want to read receipts. So you have a concept called read receipts in WhatsApp. You have single tick, you have double tick, you have a blue tick. So that is needed for sender, right? So that is not needed for receiver. So what receiver needs? Receiver needs a notification. So while receiving data, you need some notification. So receiver doesn't bother about single tick, double tick and blue tick, right? So sender needs blue tick, sender needs double tick and all. But publisher subscriber needs notification, because when the message has been received on the receiver's phone, that has to be notified on the home screen. That is why notification function will be written in the subscriber program, but not on the publisher program. On the publisher program, we are not bothering about notification. On the subscriber program only, we are bothering about notification. Who has to be notified? The receiver has to be notified when I'm sending a message. So there is no need of pushing a notification for my message on my mobile phone, but the notification has to be pushed on the receiver's mobile phone, because that is needed, because the receiver has to see that message. In order to see that message, what people are doing there, people are pushing a notification. Okay, publisher doesn't need notification for the sending message, but for the sending message, publisher doesn't need notification. That is why I have not written any notification function in publisher program. But in the subscriber program, this fellow needs notification, otherwise they cannot see the message. So that is why notification function is defined in the subscriber program. That is what you have to understand in differentiating the programs. So you can easily understand when you have a notification, that is subscriber program. So if you don't have any notification, that is nothing but publisher program. So let me talk about a sensor. So I'm using a sensor. So let me show you that sensor. I'm using soil moisture sensor. Okay, which is used to identify the moisture content from the soil. So let me click on images. So let me see the pinout. Okay, so that it will be helping you how I connected. How is this? Okay. So you can able to see, let me zoom it for you. Okay. So you have 4 pins, you have an electrode. So this is an electrode which is dipped into the soil. And also you have an amplifier circuit here. So this is like a comparator will be there, and you have some operating LEDs also. But when in talking about connections, you have 4 connections here. VCC, ground, that is for power supply. You have AO and DO, analog output and digital output. So in IoT, generally in many cases, people use analog rather than digital. Okay, so analog output is for accuracy, but when in digital, it doesn't bother about how much amount of moisture is there. But in analog, we used to understand how much amount of moisture is there. Okay, so AO is nothing but analog output. So that analog output will be in the form of voltage, right? So that voltage will be converted into digital by ADC inside Arduino. So I'm using Arduino Uno. Let me show you that. Arduino Uno. I don't know how many of you are aware of it or not. This is very popular again in the microcontroller community. Arduino is an community, open source community again. So it will be having a microcontroller. So this microcontroller is having internal ADC. So that will be converting analog to digital. Okay. So you have a 10-bit ADC. So you have 10-bit ADC. So when you have a 10-bit internal ADC, then obviously it will be converting analog value in the range of 0 to 2 power 10 minus 1. So by using successive approximation method, it keeps calculating the analog voltage into a digital value in the range of 2 power 10 minus 1, 0 to 2 power 10 minus 1, which is like 0 to 1023. And when you look at Arduino Uno, okay, so let me look into pinout. Arduino Uno is a microcontroller. It's very popular. Okay, so it's a low cost computer. Let me take this picture. Okay, it is a bit clear. Arduino Uno is a microcontroller where you can able to connect sensors. Okay, so you have A0, A1, A2, A3, A4, A5. So these are the analog pins. So you can connect analog sensors here, and it is also having 14 digital pins: 0, 1, 2, 3, 4, so on 13. So now the sensor is connected to A0. Okay, I have connected sensor to A0, which is like analog line 0. I'll be using a programming language called embedded C++. I will be writing that programming onto this computer electronic microcontroller. So I'll be showing you how to write a program onto this microcontroller, what is this program and what are the instructions that needed. So that for me, if you want to know what is Arduino, you can go to the website called, everything is open source, arduino.cc. Google Colab is open source, Arduino is open source, MQTT protocol is open source, Raspberry Pi is open source. So you'll have all the documentation available for everything in the Google. Okay, in the respective community pages. Python is also open source. Arduino is just a computer, okay, which is holding a microcontroller, and this microcontroller will be programmed by using Arduino IDE. So there is an IDE. There is a software called Arduino. So on my laptop, I have Arduino IDE. So this Arduino IDE is installed on your laptop. It should be downloaded. Okay, so you can download the software. So it's very simple. You need to click on downloads. If you're using Windows operating system, you have to download from Windows App Store. Otherwise, you can download zip file also. If you have Linux operating system, you can download this and you can install it. If your operating system is Mac, also it is supported. So in Linux, it Mac, in Windows, it is supported. You can directly install. Okay, on Raspberry Pi also you can install, but your Raspberry Pi should be Raspberry Pi 4. Otherwise, your Raspberry Pi will become slow. Okay, so here you can download this software. So this is open source IDE. So when you install this software, you'll get something like this. Let me click on new window. Okay, so let me close the previous file. Okay, so this is called Arduino IDE. So what is this Arduino IDE? This is a IDE is nothing but a place where you can write program and where you can compile your program. So compiler is also built in Arduino IDE. So you can compile your program. So compiling is nothing but a process of converting a high level programming language into hexadecimal language, because these are called cross compilers, right? So cross compiler will be converting high level programming language into hexadecimal language. So that hexadecimal language, I have to copy that hexadecimal language onto the microcontroller. So that is called burning process in embedded systems. So you need a programmer that is also built in Arduino IDE. So Arduino IDE is having editor, is having compiler, is having programmer. So what is programmer? Programmer is nothing but uploading the program onto the Arduino board. Okay, so let me connect Arduino board with my system. Okay, so give me a second. Let me connect. My operating system on my laptop is Ubuntu. If it is Ubuntu, it is a bit simple for me to develop various kinds of applications related to IoT and machine learning and compared with Windows. Because Linux is open source, right? Again. Okay, so ls space ls USB. Okay, let me type ls USB. When I type ls USB, it will list out all the USB ports available on the system here. But for Windows, you have to go for device manager. So in Windows operating system, you have device manager. In the device manager, you will have ports, PORTS ports. So here you have to type ls usb on Ubuntu, on Linux. So it will be showing Arduino is connected. Okay, so in the device manager in Windows operating system, after connecting Arduino, what you have to do is you have to go to device manager and you have to see whether you have Arduino connected or not. If it displays Arduino connected, then it means that everything is good enough. If not, you have to install the device driver. So if you install the device driver, then this board will be, the name will be visible on the device manager of Windows operating system. But in Linux, so automatically driver will be installed, so no need to install any driver here. So ls usb is nothing but which list out all the USB peripherals connected on the laptop here. And when you type ls space /dev, so this is nothing but a place where you get all the IDs related to the devices that are available on the laptop. ls space /dev. So when you hit enter, it will be displaying all the data related to the devices, that all the device IDs related to the computer. Okay, so we have a device ID called TTY ACM0. Okay, so please remember this, because I'll disconnect the Arduino now. So you cannot find TTY ACM0. Okay, now I have disconnected Arduino. So let me type the same command again, ls space /dev. Now you cannot find TTY ACM0, because that is the virtual ID assigned to Arduino. So when you connect hardware, then only you can able to see that. In the similar way, in device manager also, in Windows, in device manager, when you connect Arduino, then only you can able to see the Arduino port number like COM3, COM4, COM5, COM6, and so on. When you connect, then only you can able to see. So here the port ID will be assigned in such a way that TTY ACM0. Sometimes you'll get TTY ACM0, sometimes you'll get TTY USB 0, and so on. Okay, you have to identify what is a port number. Okay, that port number you have to specify in the IDE. Okay, so the port number assigned as of now is TTY ACM0. So let me go to tools. Let me zoom it for you. So here in tools, so as Arduino IDE is supported for different boards. Okay, in Arduino is a community, so which is having Arduino software. Arduino software, you have different types of boards connected to it. So you have to select the board first, and then you have to select the port number. So here the board is Arduino Uno, so we have to select Arduino Uno. Okay, if not, you have to select the respective board. Okay, so you have to select the respective board if it is not Arduino. In the similar way, you can also program Wi-Fi chips. So you have to select the board. Okay, so before you program it. So here we have to select Arduino Uno. That is the board which is available with me right away. And port. So as I said, port is also very important. So to which port this Arduino board is connected. So you can able to see the Arduino board serial port as /dev/TTY ACM0. So that is the port ID assigned with Arduino. Okay, in the Windows also you have to do the same settings here. You have to go to ports, you have to select the respective port number, and you have to go to board and you have to select the respective board. So this too has to be done before you start the program. Then only this program will be compiled accordingly, because every board will have a unique microcontroller. So always your microcontroller will not be constant. Okay, so your microcontroller will be changing from board to board. In Arduino Nano, you'll have one microcontroller. In Arduino you'll have one microcontroller. If you are programming for Arduino Nano, you have to select Arduino Nano, and thereby, because instruction set will be varying from board to board, so you have to select the respective board before you compile before you create a program. So let's jump. Now the board is selected and the port is also selected. So let's jump into the program. So here we have void setup. The programming language is embedded C++. Okay, and you have two different functions called void setup and void loop. So in Arduino programming, so these are the built-in functions. So the built-in functions are void setup and void loop. You can see the default comment also. Put your setup code here to run once, which means that the setup function will be executed for only one time. But when you jump into void loop, what is the statement here? Put your main code here to run repeatedly. If you want to repeatedly, if you want to iterate your code, then you have to put it inside loop. So these are the two functions which are available in Arduino IDE by default. So in the setup, what we have to do, we have to write the program which has to be executed for only one time. In the loop, you have to write your logic that has to be iterated until the power supply is off. So here what we have to do, we have to read the data of sensor inside loop, and we have to declare the sensor where it is connected inside setup. So here say I have moisture sensor int moisture sensor is connected to A0, okay, equal to A0. So I have declared a variable called moisture underscore sensor equal to A0. So with integer data type. So here inside setup, what I'll do is I will declare it as an input peripheral. So by using a function called pin mode. So pin mode, the name itself says, so pin mode is a built-in function. You can see the color. Okay. If it is not built-in function, say if you type Madhu, okay. So Madhu is not built-in function. That is why it is not converted into orange color. All the built-in functions in Arduino IDE will be converted into orange color, so you can easily identify. Sometimes what people write is, if I ask you to type pin mode, people type pin mode like this. So this is not built-in function, because M should be capital. Okay, that's the difference in the syntax. Okay, the first letter should be small and the second letter should be capital enough. So here pin mode. So what you have to pass? You have to pass to which pin it is connected. So it is connected to moisture sensor, which is nothing but A0, and sensor is always an input peripheral. So you have to mention input. So if it is output peripheral, you have to mention output in capital letters. If it is input, you have to type input in capital letters in the second argument. In the first argument, what you have to pass, to which pin it is connected. It is connected to pin called A0, but A0 is declared as moist. It is stored in moisture underscore sensor variable. So that is why I have written pin mode of moisture underscore sensor comma input. So and then what you have to do is you have to send this data to the UART port. Okay, so you have to send this data to UART port. In UART port, so you have to configure the speed of serial communication. You have to configure the speed of data rate when you're transmitting the data. So here what we do is we have to talk about serial S capital serial dot begin. So what is a serial dot begin? Initializing the UART port, okay, with a certain speed. So the default speed is called baud rate. Generally, the speed in the serial communication is called baud rate. So we have to mention the default baud rate. So this is a programmable baud rate. So you have to mention the default baud rate as of now. So serial dot begin of 9600. So what is this 9600? 9600 BPS is the speed of serial communication that has been communicating the data rate from Arduino to Raspberry Pi. So the data rate of data that is pushed from Arduino to Raspberry Pi is 9600 BPS. So we have mentioned that in moisture sensor is connected here and the speed of communication is 9600. Now what we have to do, we have to read the data from sensor and we have to send the data. So to read the data from sensor, so let's say int m equal to analog read. Why we are using analog read here? Because the sensor is analog and the sensor is input. So that is why analog read. Read action will always be done on input peripherals, and this input is analog peripheral. That is why we are using analog read. So you can see the syntax, right? A should be small and capital R should be, R should be capital here. Analog read. From which pin we have to read the data? From moisture sensor. So from which sensor we have to read? From moisture sensor. So here, what happens here is the data which has been read is nothing but a voltage, right? So hope you're aware of it. In IoT, you have a sensor will have a voltage. Voltage will be converted into a decimal value, right? So into a decimal value by this function. So equivalent voltage. So say if you have a voltage of 5 volts, so the equivalent value is nothing but maximum value of ADC. So the maximum value of ADC will always based on the resolution size. The resolution size of Arduino Uno is 10-bit. So thereby the maximum value will be 2 power 10 minus 1. Okay, 2 power 10 minus 1, which is nothing but 1024 minus 1, which is nothing but 1023. So the maximum value is 5 volts. You will get 1023. The minimum value is 0 volt. So you will get minimum value of ADC. So it is 10-bit, but the minimum value is 0. Okay, always. So if you have a value, if you have a voltage called 2.5, then what will happen? 2.5. So here 2.5 divided by maximum voltage, which is 5 into 1023. So you will get something around 511 point something, like 5, you can write 511. So for every voltage you have a digital value. So that digital value will be stored in a variable called m. So we wanted to push this m value to the Raspberry Pi. So if you want to push that m value, that is nothing but data. So that data has to be pushed to Raspberry Pi. So if you want to push that data to Raspberry Pi, what we have to do is we have to put it in the format. We have to put it in the frame. Okay, let me create a frame. So I'm creating my this is my format. General I used to do this, okay, in this way, creating a format, or you can say creating a data frame. Okay, I'll create a data frame which is like serial dot print. I'll put some start of the format. So here hash represents that data is started. Okay, data is started, and serial dot print of m. Okay, so this is nothing but data. M is nothing but data here. So serial dot print of m, after m, what I'll do is I'll put negation. Okay, this is nothing but end of the negation is nothing but data is ended. Okay, so in between hash and negation we have this m value, right? So it is binded in between hash and negation. Serial dot println. So what is this println? New line. So every time what will happen, this frame will be entered in every new line. Okay, so let me keep some delay. So let me have delay of 3000. Okay, so 3000 represents 3 seconds of delay. Okay, delay is a built-in. If you see in orange color, that is nothing but built-in. Okay, so that is why Arduino is widely used. So no need to write from scratch. Everything you have a built-in libraries. So when you have built-in library, you can access them. So whenever you require it, so you have to understand which respective function has to be accessed. So if you go through the documentation of Arduino, you can easily understand all this. So this is a very simple program. So let me save this program. Let me click on save. So this program will be saved, and then you have to compile the program. So you have to click on the tick mark. Okay, so you have the op menus here. You have to click on the tick mark, which is verify. So your program will be verified. If there is any error in the program, that error will be displayed here. If there is no error, so you'll get done compiling. Okay, so it is compiling the program, you'll get done compiling. Okay, so everything is done, so there is no error. So it is saying that this is the this much amount of program space is needed. Okay, so 6% of the program space is used by this program. After this, what we have to do is we have to upload this program into the Arduino board. So if you want to upload this program, so you have to hit play. Okay, so when you upload, click on upload, you have to upload the program. So it is saying permission denied. Okay, so let me give the permission through command terminal. Okay, so where is this? So I'm using Ubuntu operating system. That is what is asking permissions here. So sudo chmod a plus rw/dev/tty/acm0. Let me enter the password. Okay, so let me hit play button. If I hit play button, the data will be the program will be uploaded into the Arduino board. So you have a serial monitor here. It will display the it is used for debugging. Okay, so you can able to see the data. Let me zoom it for you. You can able to see the data frame. Okay, it is showing hash, the digital value of analog voltage, and the negation. So that value will be in between 0 to 1023. So based on the dry and wetness of the soil, the value will be keep altering there. So this is the data frame which is been transmitting from Arduino. This is a debugger. Okay, so it has a built-in debugger. We can able to understand what kind of data it is transmitting out. So this data will be read by Raspberry Pi, and we have to write some program there. Any doubt?
Sir, here Arduino different than Raspberry.
Hello, so come again.
Here Arduino, it's different. It's different symbol here, not like a Raspberry Pi.
No, Arduino is like a computer controller, microcontroller. So I'm using microcontroller to read the data from sensor,
Okay.
and then I'm pushing the data to Raspberry Pi. I have not written any program yet, but I have to write a program to push this data to Raspberry Pi. So as of now, Raspberry Pi has to read data now. So let me see the chat if there is any question. Okay, so let
So
me.
Madhu sir, this sensor is already means installed somewhere physically.
It is connected with my Arduino.
Acha, acha, okay. No, that moisture level, how is it displaying?
The moisture sensor will be converting that moisture into voltage.
Okay.
So that voltage this microcontroller is reading and converting into digital value.
Okay.
So that digital value is printing on the monitor according to the program.
Okay. Fine.
So in programming microcontrollers, we need cross compiler. So general purpose compiler, we cannot use it here. So in embedded systems, we need cross compilers. So that's the cross compiler will be converting the high level programming language into hexadecimal language, because microcontroller needs hexadecimal language. But when you look at C compiler, so when you look at something like GCC or C compiler, so they will be converting high level programming language into executable file, right? So it will be converted into byte codes and all. So byte code, you cannot use it in the microcontroller. We need hexadecimal code here. So that's the difference between when you look at Java compiler or when you look at C++ compiler. So you will be getting .exe file. So .exe file you cannot upload into the microcontrollers. So microcontrollers will be understanding only hexadecimal language. So that is why cross compilers comes in. So what is the difference between C and embedded C, C++ and embedded C++? So the syntaxes will be same, but the compiler is different. So in C, you have a general purpose compiler which will be converting C programming language into a .exe file. So you will have a binary file there. But here, when you look at cross compilers, C, embedded C comes in. So what is this embedded C? The difference is only that this embedded C can able to read data from hardware. So it is mainly used in hardware based applications. And embedded C compiler, what is this embedded C compiler? Something like a cross compiler, something like Arduino or something like Keen Microvision or something like Micro C. You have different types of cross compilers for any programming. You have for embedded C, you have one set of cross compilers. For embedded C++, you have the another set of cross compilers. Embedded Java has different sets of cross compilers. So cross compiler is needed in embedded system, because all the embedded system, not only Arduino, you take any microcontroller, it needs hexadecimal language. Hexadecimal language is only the language which is understandable by any microcontroller. So that is why we need only cross compilers. So Arduino is one embedded C++ cross compiler. So that's the difference. For practicing the basic things, you can use Tinkercad. Okay, so Tinkercad, so tinkercad.com. Okay. So Arduino, so in the IoT architecture, so if you look at the IoT architecture, okay, so let me jump into IoT architecture. So here we have sensor. So sensor itself cannot push the data, right? You need a computer to read the data from sensor. So that in that place, people use controllers like Arduino or simple like AVR microcontrollers, microchip microcontrollers, or Philips microcontrollers, or there are different types of vendors. Okay, so every vendor is having their own architecture of microcontroller, and people use microcontrollers to read the data from sensors. So once the data is read, so that data will be pushed to IoT gateway. So Raspberry Pi comes in IoT gateway. So you cannot use Raspberry Pi in collecting data from sensor, because in when you look in agriculture example, okay, you have multiple number of sensors. You cannot put a Raspberry Pi for every sensor. Why? Because the Raspberry Pi cost is 4,000 rupees. So sensor cost is only 120 rupees. So for every sensor, if you keep putting Raspberry Pi, the cost of the IoT architecture will get increasing there. That is why we cannot use Raspberry Pi in for every sensor. That is why people use something like Arduino or something like low end microcontroller where the cost is very less. So that is why people use Arduino because the programming is very easy. When you go for the other microcontrollers, okay, rather than Arduino, then you need to understand the architecture, because you have a RISC architecture, right? So you have a microcontroller architecture, because microcontroller will be holding a CPU. Every CPU will have a certain architecture. If you go for the other microcontroller other than Arduino community, so what Arduino community did here, Arduino community is taking care of architecture. It is giving a high-end API in terms of function calls. So when you look at function calls, it is very easy. It is very easy and user friendly, right? So we can easily understand. When you look at analog read, you can easily say that yes, the data, this fellow is reading data from analog peripheral. So when you look at
Sir, my question is there. Hello, sir.
Yes, sir.
Sir, since Arduino is a ARM-based architecture, right? Hardware,
AVR
right?
or ARM, so it has both variants.
Okay. So does it support the interrupts also, sir?
Yes, external interrupts and internal interrupts are also available on Arduino, sir.
Okay, thank you.
Yep. So sometimes in sensors also you have priority sensors, right? So then people use interrupt service routines. They'll give priority for each sensors, and they keep writing some program on Arduino, and they'll push according to it to the IoT gateway through a wireless network.
Sir, you mean Arduino get the sensor and contact with the Raspberry?
Raspberry Pi, come again?
I mean the sensors contact with Arduino and Arduino contact with Raspberry, or different?
Your voice is not clear. Arduino?
I mean sensors contact with Arduino and Arduino contact with Raspberry. You mean?
Yes. Sensor is connected to Arduino. Arduino is connected with Raspberry Pi.
Okay, fine, sir.
So Hackster is also good, but you need a simulator kind of thing, right? So Hackster is all about, it will display all the projects and all, right? But you don't have any simulators for it. So you need a simulator, right, for executing different kinds of projects. So Tinkercad, you have simulators on the installed on the platform, so you can use those simulators for running various kinds of programs on it. So Arduino and Node MCU, when we talk about this, so Arduino and Node MCU can be programmed through Arduino IDE. So that is one. And the second thing is, like, in Node MCU, people these days are writing MicroPython scripts, because that is a Wi-Fi chip, right? So in Wi-Fi chip, you have a flexibility of connecting with database servers directly without any IoT gateway and all. So in sometimes people use embedded C++, sometimes people use MicroPython on Node MCU. So, and also in microcontrollers, you have microcontroller operating system, MUCOS operating system is there. So if you are developing, low end applications, then, sometimes people use, MUCOS operating system, and people use different types of operating system concepts on the microcontroller. So it's up to the context of the application. So Python, it is again a combination, a programming language which is created from Python. So you have a similar syntaxes, because Python is nothing but you write program in Python that will be again converted into C programming language, and that C programming language will be fed to the compiler on the backend. Arduino IDE is a community, right? So it is supported with all third-party boards. So if there is any board comes out in the market, okay, then developers needs an IDE to program it, right? So what semiconductor company, what microcontroller vendors are doing there is, they are, instead of creating their own IDE, they are giving a support for Arduino. So when they give support for Arduino IDE, you have a high library API access, right? You have a library API access, and people can able to program it by using Arduino IDE for all the third-party boards. So in Arduino IDE, you can use boards manager. So you have a boards manager here in tools. You have boards manager. Let me zoom it for you. So this boards manager will be, you can use it for installing third-party boards. Because when you look at ESP, so in my laptop you have ESP8266 boards, something like Node MCU, Wi-Fi chips and all. So these boards are not boards from Arduino; they are like third-party boards. So they can be, you can download them from boards manager. So in the boards manager, you have different types of variants. Okay, so you can download the respective family onto your Arduino IDE, and you can start programming them by using Arduino syntaxes. Because in Arduino syntaxes, it is user friendly, right? So no need of understanding the architecture. You can easily, for interrupts, for timers, for everything, for ADC peripherals, everything, you have a library, and using that library, you can, program that. So that is the advantage of using Arduino IDE. So there is a library support. So library support will also be there. If you click on, Sketch, okay, if you click on include library, so as it is open source, you will have library manager also. So in Sketch, in manage libraries, you'll have this library manager. Okay. So through library manager, you can download any library, say, and that library, it will be downloaded onto your Arduino IDE. So you'll have a library manager. You'll have hundreds of libraries on Arduino for Arduino IDE. So you have to search for that respective library, and then you can start programming it. Okay. So it supports all types of libraries here. Okay, so that is the flexibility given by Arduino IDE. So no need to write from scratch. Everything you will have a library written by someone else. They'll be posting to Arduino community, and we can download that library, and you can start scripting it. So if you're good at hardware, then you can create your own library and you can start using it. Okay, so that is also fine. So people who are writing libraries, they are good at hardware. They can understand what is happening on the backend. So based on that, they will be writing some library API. So that API will be calling it through Arduino program and all. Okay, let me jump back to the use case. Okay. Hope I answered all the queries. Okay, so let me jump into the use case. Okay, so this fellow is Arduino is pushing data to Raspberry Pi. So by the through the USB port. Okay, so through the same USB port, it will read the it is pushing the data. So let us write a Python script. Okay, so we have to write a Python script now. So let me clear all this. Let me write a Python script to read the data. Sudo space nano space arduino.py. So this is the program which I want to write, a new program. Now here I have to read data from Arduino. So my target of this program is to read data from Arduino. Okay, so read data from Arduino. So how Arduino and Raspberry Pi are connected? Arduino USB is connected to USB port of Raspberry Pi. So always Arduino, Italy version. Okay. So there are some Arduino is open source. Okay. So there are local vendors who are making in India also. If you look at the original board is from Italy. So if you have Arduino Italy version, so always you will get the ID as TTY ACM0 only. If it is local made, sometimes you'll get ACM0, sometimes you'll get TTY USB 0. Okay, the ID will be a bit different from local versions to global version there. Okay,
Sir,
so
the performance is same between the original and the clone one?
Yes, the performance is same. The only difference is the quality of board, the quality of PCB which is getting printed. The if you look at the original one, it will be a bit stronger than the local made. The remaining else will be same because they use the same microcontroller.
Okay, sir. Okay, thank you. Thank you.
So here we have to read data. So when data is pushed through USB port, okay. So the USB port is nothing but TTY ACM0 for this Arduino. So here what we have to do is we have to import a library. So let me import a library called serial. So serial is a built-in library in Python. So to read the data from serial ports. So USB is also serial port here. So it will read the data from the serial port. So to access a serial port, we have to create a serial object. So we have to create a serial object, say SCR equal to serial dot serial of the port number. So /dev/tty ACM0 and baud rate. So in the Arduino program, we have written a baud rate called 9600. So we have to mention the same baud rate here. So if your baud rate is changed, say sometimes people write 19,200, then you have to mention the 19,200 here. So baud rate is a programmable baud rate. And timeout, connect, disconnect timeout. So it is 0.5 seconds. So sometimes if you have any loose connection, it will try to reconnect again. So which is timeout 0.5 second. So here what we have to do is we have to read the data from the serial port. So to read the data from serial port, so let's have this, the logic in Arduino is written inside loop, right? So I have discussed about this. This loop is nothing but infinite loop. It continuously read the data and pushes the data. So here also on Raspberry Pi, what I do is I'll write an infinite loop. So while true colon. So while true colon is nothing but an infinite loop here. So here what I'll do is first I will check whether data is available or not. Okay, to check data is available or not, we have a function called if scr.inWaiting. So this is a function which always talks about whether data is available to read or not. It is in queue or not. Okay, so you have a serial buffer. So you have a serial buffer in microcontrollers or in Raspberry Pi. So that's if you have some data in the serial buffer, then obviously in waiting will be equal to length of the buffer. So if you have 5 characters available in the buffer, then serial.inWaiting will return 5. So if you have 4 characters in the buffer, so it will return 4. So based on that, it will try to identify. So now what I'll do is I'll put greater than 0. If any data is available, then obviously it will be greater than 0. If it is greater than 0, what I'll do is I'll read the data. So let me put it in the variable t equal to scr.readLine. So So t equal to serial dot read line. So print of t. Okay, print of t. So let me print the data here. Okay, let me run this program. Control X, Y, enter. Sudo Python 3 Arduino.py. So now what will happen here is like, it will read the data, from Arduino board. So this program is reading the data from Arduino board. Arduino is now connected to the USB port. So from the USB port, it is reading the data. You can able to see it. So you can able to see the data like B. It is coming B. So B is nothing but, bytes. That is the data is encoded. The data is encoded. So now we have to decode the data. Because when you see B in Python, when you see B in Python, so that is nothing but bytes data type here. So now we have to decode the data. So if you decode, then only you can access this value. Okay, without decoding you cannot access. This isn't protected. Okay, so now we have to decode the data. So every line is printing with B. Now I'll decode the data by using Python script. So let me jump into the same program. So here what I'll do is, if you want to decode, so we have a method called decode. Okay, so t equal to t dot decode of. So there is a standard called UTF-8. So you can able to see this when you're developing web pages also. So UTF-8, this is a default encoding and decoding standard that is heavily used in Python 3. So let me run the program. So Control X, Y, enter. Let me run the program. If I run the program, now you cannot see B. You can see only the data. So which means that your data is decoded now. Now you can access hash, you can access 3, you can access 5, you can access 4 and all. You can access the individual data there. Okay, now let me access that individual data. So if you want to access the data, what we have to do is we have to split, we have to access only the respective data, right? So you have to remove this hash, you have to remove this negation, and also you have to remove this space. This space is nothing but new line. So that is been created by using /r and /n. So now we have to split this data. So by using a simple syntax, okay, by using a simple script in Python, we can slice it. So t equal to t dot split of, you can write hash. So let me split the value of t by using hash. Okay, so okay, now let me show you the output. You can understand. Dot split is nothing but which splits the value t. So it splits the entire value into pieces and pieces by taking hash as reference. So let me run the program. If I run the program, you can able to understand that the entire string is split into two parts. The first part is empty space because there is a hash there, and the second one is like the rest of the string. So in the rest of the string, if you see, you have the unwanted data in the second index, right? But in the second, but index always starts with 0. So in 0th index, what you have here, empty space. So that is not needed. So what we need, this index we need, right? So in this index, what you have value, sensory value, followed by negation, followed by /r, followed by /n. So we have to remove this negation, /r and /n. So that is called slicing. So we'll do slicing here. Let me simply select. Let me select the first index. Okay, let me select the first index as of now. Let me run the program. If I run the program, you can able to see only the value followed by negation, but /r and /n is invisible here, but you have /r and /n. Okay, now you have to remove this last 3 characters. So what are the last 3 characters here? Negation, /r and /n. So let me remove that. Let me jump into Arduino program. So here what I'll do is I will remove that by using index. Okay, t equal to t of colon -3. So colon -3 is nothing but the last 3 characters. The last 3 characters will be removed from t. Okay, t equal to t of colon -3 is nothing but the last 3 characters will be removed from t. Thereby, you will get only the sensory value. Okay, let me run the program again. You can able to see only the sensory value now. There is no negation. There is no new line also. So in the previous output, if you see, there is a new line which is printed there. But here, you don't have any new line. Okay, so you can able to see them successively. So they are there is no negation here. Now the data has been read from Arduino. So this data I want to push to Google Colab. So now the data has been collected by Raspberry Pi through USB port through this program. So let me push this data to Google Colab. So if you want to push the data to Google Colab, so let me use the same syntax. Okay, so let me import paho.mqtt.client as MQTT. So let me import the same logic here. Let me create a client object. Let me create a client object, client equal to MQTT.C client, and let me connect with broker. So to connect with broker, you need a broker details here. Broker is equal to broker.hivemq.com, and port number equal to 1883 is the port number. And topic, what is the topic? Topic is nothing but NIT/NITW/IoT, I guess. So is it the topic? I have to check my topic. Is the topic NITW/IoT? Okay, so that is the topic. So we have to publish the data. Okay, so let me connect with broker, client.connect of broker comma topic. So here let me print broker connected, and now it is connected with broker. Now let me push data. Okay, so to push the data I have to push it from here, okay, because data is available in T. So client dot publish of topic comma str of T. Okay, str is nothing but typecasting the data into string. So print published. Okay, let us give some time delay. So time dot sleep of 3. So time dot sleep of 3 is nothing but 3 seconds of delay. Okay, so let me have import time. Okay, because I'm using time dot sleep, I have to import time library. So time is a built-in library. Now here what is happening here? It reads the data from Arduino and then it pushes the data to Google Colab. So hope you're aware of client.publish and all. So Control X, Y enter. So let me run the subscriber program, because subscriber should be ready to receive data. So now the broker is connected, subscriber is ready. Now let me run publisher program here. So if I run publisher program, now publisher program is I have added in Arduino.py only. So Arduino.py. Okay. Now your data will be published. So what is it saying? If port okay, so once again this is changing something out here. Let me shit. TDY ACM 0, 9600, timeout. So where is this line 24? So in line 24 there is a method broker comma port broker.hivemq.com. So line broker.hive, what is the mistake? There's a mistake. Broker dot 1883. Okay. Mistake is here. We should not pass topic, we should pass port, right? Some simple silly mistake. Since time is running up, I'm typing fastly. That is why all this will happen. Okay, so the data is sending from Raspberry Pi to the Google Colab. Okay, so this terminal is alias Raspberry Pi terminal. So this program is reading data from Arduino and pushing data to Google Colab. So on the Google Colab also you can able to see the same data which is getting printed with B. So which means that again data is encoded. Okay, so data is encoded automatically. So we have to decode it. So tomorrow we'll continue from there. Okay, so this data we have to store it in the database server. So tomorrow I'll show you how to create an API so that this Raspberry Pi itself pushes the data to database server and all. So any questions? I'll share this program through Git. Okay, I'll share the main program directly onto the Git, because this Git will be holding some sample programs. Okay, so I'll write final.py. Okay, I'll create. So Arduino program is same. So I guess there is no change in Arduino program. Arduino program is same, the same program. Okay, so there is no change in Arduino. I guess Arduino.py is something different. Okay, so I'll change this. Okay, so I'll do one thing. I'll write main.py. Okay, so let me add a new file so that there'll be no confusion there. So I'll put main.py. So let it be the main program. Okay. So any doubts you can ask meanwhile. Let me. I want you to practice, so that is why I'm sharing all this, so that it will be easy for you, right? Because for the first time it will be easy, for it will be difficult for you to understand, grab all the syntaxes, right? So when you have this kind of reference code, you can easily develop some projects around it. Okay, so in main.py you have the main program. Okay, just now uploaded, so you can get this.